Okay, so just going over the sex-linked Punnett squares practice key. Of course, this will help you prepare for the assignment. A phenotypically normal woman carries the gene for hemophilia and has children with a man without hemophilia. So first of all, you may be asking yourself, what does phenotypically mean? I've put a link to it here, okay? And so it refers to the phenotype. These are the observable constitutions of an organism, okay? Or the appearance of an organism resulting from the interactions of the genotype and the environment. Okay, so just basically what we talked about in class. It's what is shown, okay? So what the genotype predicts or what it shows the individual will be. So, so again, it's a normal woman who carries the gene for hemophilia and has children with a man without hemophilia. So, what does the mother's genotype look like? It will be an X, right? Because we're talking about sex-linked traits. This happens to be an X-linked trait, okay? And so we have X, big H, X, little h, right? Because we have a female that has that is a normal woman carrying the gene for hemophilia. So here's the gene she's carrying for hemophilia here. What does the father look like? Well, he is without hemophilia, and so he is first of all a male, which is XY, and so he has an X with a big H. Okay. Number 3. What is the difference between a Punnett square used for regular traits and one used for sex-linked traits? You may put Punnett squares to help explain. Okay. So what I'm looking for here is for you to understand the difference between the two of them. Okay, so in a Punnett square for regular traits, we only do traits that are not connected to the X and Y or sex-linked chromosomes. Okay, so basically everything else that's not attached to the X or Y linked, right? And for this one, we have these. We just use the single letters, right? For each allele or for each trait in an individual. Putting the male on the top and the female on the side. Again, this doesn't matter, but for the purposes of our class, that's what we're going to be doing. And then their offspring in the middle. Okay, the big G coming down this way, and the big G going across this way, the little g going down this way, and the big G going across this way. Capital letters always going first. Okay, and the second one, okay, so you're comparing it to a sex-linked Punnett square. So in a Punnett square for sex-linked traits, we only do traits that are connected to the X or Y chromosomes, okay, or sex-linked ones. For example, okay, and then I give you, and this is, I think I just did color blindness or something like that, but so we have a male here who has regular vision, okay, X, big B, Y, right, with a colorblind female, okay, which is X little b and X little b. And so they cross, right? We have our males on this side and females on this side. Remember that when you're figuring out if I'm asking for children altogether or just males or just females, right? Because if we're talking about all the children here, all the children, there's 100%, right? We have 25 in each spot. But if I'm just asking about the males, it's 50-50 now, right? Because if I said how many of the males will be colorblind here, well, you would have to say it's X little by, X little by. So 100% of these kids, these boys right here, not kids, but the boys would be colorblind. Okay, if I asked how many of the girls would be colorblind, you would say 0%. If I asked how many of the girls would be carriers, you would say 100%, right? They both have big B, little b, big B, little b by their X's. Okay, so that's what I'm looking for there, is for you to understand the difference between the two. Okay, so make a Punnett square for the two people in the above question. Remember to put the male on the top and the female on the side. So the above question being this one right here. a phenotypically normal woman who has the gene for hemophilia has children with a man without hemophilia. So here's the mother and here's the father. Okay, so we put the father on the top, the mother on the side, and we cross them. Okay, and so this is what it should look like. And you can pause this at any time if you want to pause and take a look. Okay, what percentage of the children will have the phenotype for hemophilia? Well, we have 1 of all of them. Okay, so that means 1 out of 4, which is 25%. What percentage of the children will have the phenotype for hemophilia? Okay, or sorry, for non-hemophilia. Well, non-hemophilia here, even though she's a carrier, non-hemophilia. So that's 3 out of 4, or 75%. What is the genotype for the children with hemophilia? Okay, so the only time that in this Punnett square kids have hemophilia is a male, and that's X little h y. Okay. What is the genotype for children without hemophilia? Well, here are the children without hemophilia. We already saw that one here for the phenotype. So now we're going to put it down here for the genotype. So these are the 3 genotypes that would be without hemophilia. Okay. And then why did I put 3? Well, we have a female without hemophilia, we have a male without hemophilia, and then we have a female that is a carrier, right? And what is the genotype for children who carry hemophilia but do not have it themselves, right? And the only individual in that case would be the female, which is X, an X and an X, and then H, big H, and little h. So that is the corrections for the sex-linked Punnett square practice sheet.